Hi everyone, in Algebra 3, this is going to be your video for the new material in lesson 67. And what we're going to be doing in this lesson is something called anti-logarithms. So you guys have already heard of what a logarithm is. Now we're going to be solving for the anti-logarithm. So the exponent is the other name for that is a logarithm. And actually another name for the number is actually called the anti-logarithm. So in our equation, n equals b to the L, n equals b to the L. The number is the anti-logarithm. And the exponent is the logarithm. And then the b is just the base. Okay, so these are just different names, but what we're going to be solving for is actually the number. We're going to be given the base and the logarithm or the exponent, and we have to solve for what that number is equal to, and we are going to be using our calculators for this. So an example, it says, if the base is 2, find the anti-logarithm, so find the number of 4.63. So what we're doing, the example, it says, if the base is 2, we're solving for the anti-logarithm when the base is 2 of 4.63. So we're solving for 2 to the power of 4.63. And we're going to use the y to the x button, which is right here. So on your calculator, you're going to do 2 y to the x, 4.63 equals, and again, you're going to be going to 4 decimal places. So that means my anti-logarithm n is going to be equal to 24.7610. Okay, and that's all we're learning in this lesson. So this one says to use a calculator to find the anti-logarithm. So find the number, find the anti-logarithm of 4.63 if the base is 10. So it's 10 to the power of 4.63. So there's two buttons you could use. You could use the y to the x button, but on this one, because the base is 10, you could technically use the second log button. I'm just going to be consistent though and use the y to the x button. So 10 to the power of 4.63 equals, and it's a very large number, so this number, or my anti-logarithm, would be equal to 42,657.9519 if I round to 4 decimal places. And that would be your result for this lesson. Okay, so now what we're going to do is we're going to do the new problems as well as some of the word problems just to kind of give you guys a head start on your lesson. So we're going to look at numbers 7 and 8 first and then go through some of the new problems. So for number 7, it says use a calculator to find the anti-log when the base is 2 and the exponent is 5.31. So really, if you wanted to kind of ignore this, it's asking for 2 to the power of 5.31. So for number 7a, they're asking for the number if we have 2 to the power of 5.31. In your calculators, you just do 2 to the power of 5.31 equals, and that's going to give you a result of 39.6706, and that would be your result. For part 2, for B, they're asking you for anti-log of base 10 to the 5.31. So again, if you kind of ignore the anti-log, so you can see what they're asking for. It's 10 to the power of 5.31. So our number would be 10 to the power of 5.31. Now, if you wanted to use this second log button, I'll show you how that works. You would plug in 5.31 first, and then you would do second log. And that would be 204,173.7945. And that would be your result for that one. So I'm going to 4 decimal places again, just like when you're trying to solve for that logarithm that we were doing before. Okay, so for number 8's a little tricky because they actually ask you to estimate. They're not actually asking you to solve. They're asking you to estimate. And when they ask you to estimate E, they're asking you to estimate E as equal to 3. So I'm just going to estimate that. So for number 8a, it's asking you to solve for the number or the anti-log when the base is 3 and the exponent is 2. Well, now 3 to the second power is approximately equal to 9. And that would be your result. Now for B, it's saying to solve for the anti-log. So the number, when your base is approximately equal to 3 and your exponent is -2. Well, if you have a negative exponent, that means it's going to be equal to a fraction. So that would be approximately equal to 1/9. So when they ask you to estimate E, you need to estimate E is equal to 3. So please make note of that in your notes for this lesson. So anti-log is what we're solving for. So now what we're going to do is we're going to do numbers 1 through 9 together. So number 1, we have how many 3-digit positive integers can be formed from the digits 1, 2, 3, 4, and 5 if no digits are repeated in the number. Okay, so number 1 is how many 3-digit positive integers. So we're going to have 3 boxes. It says repetition is not, so no repetition, no repeating. So I'm starting with 1, 2, 3, 4, 5 different numbers. So my first space, I would have 5 numbers available. Once I've used one of them, I'd have 4 available. Then I would have 3 available. So all I would have to do is 5 times 4 times 3, and you would get a result of 60. So no repetition. There was really no other conditions on that problem, so you could have stopped there. Now we're going to look at number 2. So number 2 is the speed of the boat in still water is 16 miles per hour, greater than the speed of the current in the river. The boat can travel 48 miles downstream in the same time it took to travel 32 miles upstream. What is the speed of the boat in still water? What is the speed of the current? So the speed of the boat is 16 miles per hour greater than the speed of the current. So 16 plus W. The boat can travel 48 miles downstream. So the distance downstream is 48 in the same time it took to travel upstream. So time down is equal to the time up. And the distance upstream is equal to 32. So now what we need to do is we need to plug into my 2 equations. So I have my downstream equation, which is going to be B plus W times TD equals DD. And then my upstream equation, which is going to be B minus W times TU equals DU. So I know that my B is going to be equal to 16 plus W plus W. My TD I'm going to change to TU, and my DD is equal to 48. So when I add those W's together, I'm going to get 2W. So I get 16 plus 2W times TU equals 48. When I distribute the TU, I'm going to get 16 TU plus 2 WTU equals 48. Now for my second equation, when I plug in the B, I'm going to have 16 plus W minus W times TU equals 32. But look at that. The W's are going to cancel. So I get 16 TU is equal to 32. So therefore TU is going to be equal to 2. We're looking for the speed of the boat and the speed of the current. So I'm looking for B and for W. I'm going to plug in this 2. So I have 16 times 2 plus 2W times 2 equals 48. Well, 16 times 2 is 32. So I'm going to get 4W is equal to 16. And therefore, the speed of the current is equal to 4. Then my speed of the boat is 16 plus W. So that means the speed of the boat is going to be equal to 20. And that would be your result for number 2. Now moving on to number 3, it says Fabian took 3 times as long to fly 1,800 miles as it took Hamilcar to fly 1,200 miles. Find the rates and times of both if Hamilcar's speed was 200 miles per hour greater than that of Fabian. So Fabian took 3 times as long, so the time of Fabian was 3 times the time of Hamilcar, but the distance of Fabian is equal to 1,800, and the distance of Hamilcar is equal to 1,200. It says the rate of Hamilcar was 200 miles per hour greater than the rate of Fabian. So I actually want to solve for RF in this equation because I solved for TF here. So RF would be equal to RH minus 200. I know that distance is equal to rate times time. So this would be RF TF equals 1,800 and RH TH equals 1,200. It's a bit difficult to see, but my RF is going to be RH minus 200 times 3TH equals 1,800. And I'm going to actually divide this whole thing by 3. So this would just be distributing the TH. So that would be RHTH minus 200TH equals, bless me, 600. I know that RHTH is equal to 1,200. So that would turn into 1,200 minus 200TH equals 600. When you move the 1,200 to the other side, I get negative 200TH is equal to negative 600, and therefore TH is equal to 3. It says to find the rates and times of both. So I found TH. Now I can find what TF is equal to because TF is 3 times TH. So therefore TF is going to be equal to 9. Then I can take this and plug it into here. So that would be RH times 3 equals 1,200. So therefore RH is going to be equal to 400. My last one is to solve for RF. So RF is equal to RH minus 200. So subtract 200 from RH gives me RF is equal to 200. And that concludes this problem. That was kind of an Algebra 2 problem. So you just have to remember your distance equals rate times time. Okay, number 4. We have 3 dozen eggs and 5 pounds of flour cost $5.50. 4 dozen eggs and 2 pounds of flour cost $5. What is the price of 1 dozen eggs and what is the cost of flour, 1 pound of flour? So for number 4, it's going to be a substitution elimination problem. So 3 dozen eggs, so 3E, and 5 pounds of flour, so 5F, equals $5 or 550 cents. And then it says 4 dozen eggs and 2 pounds of flour cost $5. But remember to put on the 00 because we're going to do this in cents. Now this becomes a substitution or elimination problem. I'm going to do, probably going to just do substitution, I think. Well, it really doesn't matter. So if I do 2F equals negative 4E plus 500, and then divide by 2, I get F is equal to negative 2E plus 250. And I can plug that in. So that would be 3E plus 5 times negative 2E plus 250 equals 550. Now, if I distribute that 5, I get 3e minus 10e. Oof. 5 times 250 would give me 1250 plus 1250 equals 550. Just subtract the 1250. Add the 3e, so that would be negative 7e is equal to negative 700. So that means e is going to be equal to 100. Then for f, I have f is equal to negative 2 times e plus 250. Negative 2 times 100 would be negative 200, so that means f would be equal to 50. But remember that when I plugged in my dollars, I actually moved the decimal points over, so I actually need to move them back. So that means eggs are going to be $1 each for each dozen, and then flour is going to cost 50 cents each for each pound. And that would be yours. Now moving on to number 5, we have the tens digit of a 2-digit counting number is 1 greater than the units digit. So for number 5, I have the tens digit is 1 greater than the units digit. Now this is the next part of that. It says if the digits are reversed, the new number. So my new number is going to be 10u plus t is smaller than the original number by amount equal to the tens digit. So that means my original is always 10t plus u and then minus t because it says an amount equal to the tens digit. Now I'm going to move the u over to the left, move the t over to the right. So I would have 9u equals 8t. Now I know that t is equal to u plus 1, so I would have 9u equals 8 times u plus 1. Distribute that will give you 9u is equal to 8u plus 8, which means that the units digit is equal to 8 and the tens digit is equal to 9. And they want to know what the original number is, and the original number would be 98. Okay, and that would be the result for number 5. Number 6, again, we have the units digit of a 2-digit counting number is 1 greater than twice the tens digit. When the digits are reversed, the sum of the new number and the original number is 77. What was the original number? Okay, so we have the units digit is 1 greater than twice the tens digit, so 2t plus 1. This one says the sum of the new number. The new number formula is 10u plus t, and I'm adding it to the original, which is 10t plus u equals 77. So now if I add those together, I'm going to get 11u plus 11t equals 77, and simplified would be u plus t equals 7. Now I can plug in my u, so that would be 2t plus 1 plus t equals 7. Move the 1 to the other side. Give me 3t equals 6, which means that my tens digit is going to be equal to 2, and my units digit is going to be 2 times 2 plus 1, which means my units digit is going to be 5. So my original number, the tens digit being 2, my units digit being 5, my original number is going to be 25. Now we've already done number 7 and 8, so the last one we're going to do is actually number 9. The reason we're going to do this one is because they ask you to graph this function when it's ln of x, and really all this is going to be y is equal to log with a base of e of x. So when I rewrite this, it would be x is equal to e to the y. Now remember from earlier in this lesson, we estimated e is equal to 3. So I'm going to do that again. So this is only going to be an approximation. It's not going to be perfect. But I'm plugging into y, so this would be -1, 0, and 1. So if I estimate e as equal to 3 to the y, 3 to the -1 would be 1/3. 3 to the 0 would be 1, and then 3 to the 1 would be 3. So when I graph this, this is just going to be an approximation. It's not going to be perfect, but I would go over 1/3 down 1, over 1 up 0, and then over 3 up 1. And this would be my approximation. So again, this is just an approximation. It's not going to be the exact, but that's all we're going to do for number 9. And I hope this helps, and I hope you guys all have a great day. Make sure you guys are checking RunWeb for your guys' updated schedule, because we are going to be testing next week. Bye.